Hey everybody, let's continue trying to get rectangles on the screen by making our index buffer. Our index buffer is going to be created pretty much exactly like our vertex buffer. Similar function, in fact. Copy it. Create index buffer. And again, go look up the parameters. And again, it's a size parameter at the beginning, but the indices will have a different number of indices, and the indices are a different size. So first, the index size is going to be 16-bit. The number of indices is the number of recs times 6. And if that's not obvious, we can look back at our little diagram here, and though we have 4 vertices representing this rectangle, we have 2 triangles. We have the triangle 0, 1, 2 and the triangle 1, 3, 2, and each of those vertices in each triangle needs an index. That's what a tri-list is. It is a list of sets of 3 points. So the point 0, 1, 2 is the first triangle, and the points 1, 2, 3 are the second triangle. So 6 indices per triangle. So 6 indices times the number of rectangles, number of indices times the size of the indices is the total index buffer size. Second, usage param, again, exactly like the same rationale, same everything as the vertex buffer. Next is the format of the index buffer. Unlike the vertex buffer where we had to go through this hoopla to make this vertex declaration, here we only have 2 types of indices these days, 16 and 32-bit indices. So that works out there. Next is the memory pool, again default, since they're going to be changing this anytime. And yeah, if we were just doing rectangles, in theory we could just write 0, 1, 2, 1, 2, 3, 3, 4, 5, 4, 5, 6, you know, roughly every time. But we're going to extend this shortly to do all sorts of 2D solid shapes. So in that case, we're going to be rewriting the indices each time. So we'll just go ahead and make it dynamic to begin with. And then that last forced null parameter. Okay, let's compile this, see if it works. We've got SOK, buffer size seems about right. Cool. All right, and then again, we need to lock and fill the index, the sets of indices. So this time, our data type is going to be a short because we chose short size vertices or indices. And then I like to group my index buffer something like with a little shape to them, like, you know, maybe it's crazy, maybe it's stupid, but this way I can see each triangle in each row. The triangle 0, 1, the first triangle are those 3. The second triangle is these 3. And so our first triangle is 0, 1, 2. And our second triangle, we can look back and we could say it's 1, 2, 3. This is actually wrong. And the reason is because of winding order. The way, when we draw triangles, it's normally, you can break the triangles down into the triangles that are facing us and the triangles that are away from us. Most of the time we're drawing solid objects like models or boxes or crates or whatever. And if something is solid, we only need to draw those triangles that are facing us. The triangles on the far side of a box or a player's face or a mountain, we don't need to draw. And an easy way to throw those away quickly is to identify which of the triangles are facing toward us, which of the triangles are facing away from us. And the way we can do that, differentiate forward facing versus backward facing is called the winding order. We can look and see if this triangle is wound clockwise. If its points go in clockwise order when looked at on the screen, then that triangle can be said to be facing towards us. If they're going counterclockwise, like the triangle 1, 2, 3, you can see that's going in clockwise around the triangle. We'd identify that as a counterclockwise winding order, and our card might be set up to throw that away. Our settings on our card might be set up to throw that away. So if we simply adjust, let me double check that works, adjust our indices to be in clockwise winding order for both of them, we should get valid triangles showing up on screen. So 0, 1, 2, 1, 3, 2, proper winding order. Cool. Let's go ahead and check that all our return values are okay. Okay. Indices look good. Let's check the memory. 0, 1, 2, 1, 3, 2, junk, and then unlock. Looks good. Go ahead and set index buffer fill2d.pib. Go ahead, put a breakpoint here. Check that that's going to return okay. Cool. And then go ahead and clean it up. And it looks like I forgot to clean up the vertex buffer, so we'll do that at the same time. And there we go. 3 down, 3 to go. In the next video, we'll go ahead and set up our vertex shader.